Good morning, class. Looking at the homework 5.6.1 worksheet. This is a new one, so hopefully you're on the correct video here. If not, hopefully you realize it and you get to this one. So on the first few problems here, it says use logarithms or exponential rules to solve each problem. Show your work. So on at least the first couple problems, notice how x is already by itself. So the question is, can I solve this logarithm by some of the things that I know? And one of the rules that I know is the change of base formula. So I can solve this by taking the log of the number over the log of the base. So take out my calculator here, slide it over here for right now. So I can go log of 32, make sure you close that parenthesis, divided by the log of 6, and hit enter, and boom, there we go. Go out 3 decimal places, 1.934. And I got the first one done. Second one, same process. Log of the number, so log of 2 over log of the base. Log of 3. So log of 2 divided by log of 3. Close, make sure I'm closing my parentheses. 0.6309. 0.6309. All right, number 3 says log base 5 of 38 equals log base 5 of x. This one's tricky because many of you will want to put this as a decimal. But notice how the log bases are exactly the same. So if the log bases are the same, then these two numbers have to be the same. So x here is just simply 38. On the next one, all right, you can use the change of base here. So you could go log of 1 over log of 9. And when you do, the log of 1 divided by log of 9, you should get 0, which we do. So x is 0. All right, next one, still another change of base. Log of 24 over log of 6. So we're going to do that one. Log of 24 divided by, whoops, got to do that parenthesis, make a mistake, divided by log of 6. And we get 1.774. All right, number 6 now. Notice how the x is not by itself. So since it's in log form, I need to put it in exponential form. So my base is 5, my exponent is 4, my number is x. Notice how x is now by itself. So I just have to simply go 5 to the 4th power, which is 625. Number 7, same type of deal here. X is not by itself, so I need to change it in exponential form. So I go x base exponent equals number. So now I have x cubed equals 1331. Well, if we remember with exponents from our previous unit, to get rid of it, we take it to the reciprocal power. So now x equals, so if we go 1331 to the 1/3 power, you will see on my calculator that I'll actually get 11. Oops. Raise it to the 1 divided by 3 power, and we get 11. Same thing works for 8. X to the 1/2 power equals 4. So to get rid of the 1/2 power, I square it. Square it. 4 squared is 16. All right, 9 through 12 are a nice review of the last unit. So just like what we did in the previous 2 problems, we want to get rid of the exponent. So on this one, I'm just going to simply raise to the 1/3 power. So x equals, so if I take my calculator here and go 5832, and I raise it to the 1 divided by 3 power, sure enough, I get 18. Same thing here. What I want to do is raise this value to the 2/3 power, reciprocal. When I do, x ends up equaling 9. So again, if you want to see what I'm doing, 27 raised to the 2 divided by 3 power, and I get 9. On the next one, 11, now I have them in radical form, which means I'm going to have to change that radical to fractional exponent once it's all by itself. First one, however, I do have to divide both sides by 4 first. So I have the 4th root of x equals 81. So now, change it to a fractional exponent. So I get 1/4 to the 81st, or x to the 1/4 power equals 81. Then I want to raise it to the 4th power. So this one's going to be a fairly large number. So take out my calculator real quick here. I go 81 raised to the 4th power, and I end up equaling, wow, 43, what is that? Yeah, 43,046,000. Then I got a peek at the last one, 721. All right, on the last one on this page, got to change it to a fractional exponent. So remember, numerator, denominator. So x to the 2/5 equals 25. So now we want to raise this to the 5/2 power. Raise this to the 5/2 power. So x equals, so on your calculator you go 25 raised to the 5 divided by 2 power. And we get 3125. All right, continuing on to the back side, still have a few more problems. Here now they're all in exponential form. You want to write them, since you can't just solve for x, you have to write them in log form. So on the first one here I have log, my base is 10, my number is 0.025. Notice how now x is all by itself. That's how you get exponents all by itself. This is a base 10 one. So we love base 10 because that's what our calculator is. So I can just simply go log of 0.025. And I get negative 1.602. So on the second one, same thing. Log, my base is 5, my number is 7, equals the exponent. So now you can do change of base since it's not base 10. You have to do change of base in order to use the base 10 on our calculator. So now we're just going log of 7 divided by log of 5. So 1.209. So x equals 1.209. So on the next one, same process. We're asking ourselves, we're trying to get 2x by itself. So log base 5 of 125 equals 2x. So if I do a change of base here, log of 125 over log of 5, I plug that one into my calculator, I believe I should get 3. So log of 125 divided by log of 5 equals 3, because another way of looking at it, 5 to what power is 125? That's 3. So 3 is equal to 2x. Divide both sides by 2. X is equal to 3/2. Or I know many of you love the decimal, 1.5. On the last one here of just the general solve ones, let's take the first part and divide by 12. So I have 1.05 to the t power equals 15 divided by 12, I believe is 1.25. Yeah, so now I just need to get t by itself. It's in exponential form. Write it in log form. Log base 1.05 of 1.25. Base number equals exponent. The more you know that, the easier this is. So now we're just doing the log of 1.25 over the log of 1.05 equals t. So log of 1.25 divided by log of, whoops, forgot the parenthesis, that's going to be huge, divided by log of 1.05. So we get 4.574. That's what t equals. All right, now in these last problems, you're actually going to more than likely use logarithms to help you solve for the missing variable. So it says set up an exponential equation in the form y equals a times b to the x. I like to write it as y equals a 1 plus p to the x. However, that could be a minus p depending on the problem. So in 17 it says Jane currently pays $723 premium for car insurance. So we know that's her starting value A. If the premium increases at an annual rate of 10.05%, so that's our increase, how many years, so we're looking for T, will it take for the premium to be 1,000? So that's our Y value. So now it's just a matter of plugging in those values and solving. 1,000 equals 723, 1 plus 0.1005 to the T power. So the first thing you should do is divide both sides by 723. So when I do, 1,000 divided by 723, get a nice decimal. So what I like to do is go 1.303 ... equals 1.1005 to the T. The reason why I do it like that is now, since it's in exponential form, I can write it in log form. So log, my basis is 1.1005 to the 1.303 ... equals T. So now I know it's going to be the log of this 1.303 ... I'm doing the change of base over the log of 1.1005. So on my calculator, what I can do is, since I still have this in my calculator, I'm going log of my answer divided by log of 1.1005. Close my parentheses, and I get about 3.4 years. So I'm going to go to the nearest tenth here, about 3.4 in our case, years. All right, 18 says Jane currently pays this premium for car insurance. What rate would her premiums need to increase to result in $1,500 premium 5 years from now? So let's take a look at what the variables that we have here. Here's our A. We want P. Here's our Y. In 5 years, there's our T. So in this one, we're going to have 1,500 equals 723, 1 plus P to the 5th power. So this one's not going to require logarithms, but it's going to require us to be doing those fractional exponents that we've been doing before. So what I'm going to first do is divide by 723. So when I do 1,500 divided by 723, so 2.07 ... equals 1 plus P to the 5th power. Now to get rid of the 5th power, I'm going to take it to the 1/5 power. So I'm going to take both sides to the 1/5 power. So on my calculator, I can just take my answer, raise it to the 1 divided by 5 power. So when I do, I get 1.157. So 1.157 equals, so how these cross out, I'm left with 1 plus P. So when I subtract the 1, P is equal to 0.157, or this is 15.7% increase. That's a big increase year after year. All right. 19, it says, Jonas purchases a new car for $15,000. At what rate would this car need to depreciate? So since it's depreciating, this is going to be 1 minus P. Result in a car being worth $5,000 in 10 years. So that's the future, that's the initial value. Here's our future value. Here's T. We want P. We want the rate. So $5,000 is equal to $15,000. 1 minus P to the 10th power. So divide both sides by 15,000. So this one's done exactly like the previous one. So I get 0.3 repeating equals 1 plus P to the 10th power. So to get rid of the 10th power, we raise to the 1 over 10th power. So when I do that on my calculator, so what I have to do is I have to go 1 divided by 3, which is like a decimal, and I need to raise it to the 1 divided by 10 power. Whoa, it didn't take my divide. So let's try that one again. 1 divided by 3 raised to the 1 divided by 10. I get 0.896. So 0.896 equals 1 minus P. So when I subtract the 1, so if it helps you, go subtract the 1. You'll see it's negative 0.104 equals negative P, so P equals 0.104, or it is decreasing by 10.4% decrease. Or I should say decreasing by. Alright, number 20 says, Jonas purchases a new car for $15,000. Each year the value of the car depreciates by 30% of its value of the previous year. How many years will the car only be worth $500? Okay? So now, here's your here's your A, so here's your Y, here's your R, or your percentage rate. We want to know T. So this one's going to require us to use some logarithms. So, to set up this equation, we'll have 500 equals 15,000, 1 minus P to the T power. So now to solve, whoops, I apologize because we know what P is. So I'm going to just kind of cross this out right here and put 0.3. So if I divide both sides by 15,000. So 500 divided by 15,000 is 0.03 repeating, 0.03 with repeating equals, I can look at this as 0.7 to the T, 1 minus 0.3. So now I can write it like a logarithm. Alright, sorry about that. Let's get back here. So now, since it's in exponential form, we're going to write it like a log. So log, my base is 0.7, my number is 0.03 repeating equals T. So now if I do change of base, log of 0.03 repeating over log of 0.7. So should equal my T. So now let's go log. Now what's nice is I still have that answer of my answer divided by log of 0.7 equals 9.54, or since we're rounding about to the 10th, we would say about 9.5 years. All right, so this ends 5.61 worksheet.